In this video, we're going to take a look at the Visual Basic Scripter. Now, this is an advanced function of Mach 3, and it's a very powerful system in Mach 3. It allows you to modify and change the functionality of the program in a lot of different ways. Most of the buttons and controls in Mach 3 are hard-coded to particular OEM codes within the program. In the screen designer, when you put a button on a screen, that button can be told to do various jobs. During the course of this video, I'm going to be running three programs primarily. Number one is the customizing screen document. So I have a PDF viewer open which can show us in section 6.2 many of the various OEM codes and controls for some of the things within the program. The second thing we're going to be using is the screen designer itself. Whenever you're writing scripts, it can be handy to open the screen designer and take a look at the controls which are on Mach 2's or Mach 3's screens. For example, the Edit G-code button. If we double click it, we can see that it is set to OEM code 115. There is no Visual Basic script within it. Other buttons, however, such as the Display Mode button, contains within it no OEM code and simply executes a Visual Basic script. If you take a look at that button script, you can see it's fairly simple. It's only about 10 lines long, and it does a Visual Basic solution to switching the controller from one method of toolpath display to another method of toolpath display. So the question often comes up, how do I write such a script? How do I do it, and what can I do with it? As our example in this case, we're going to write a quick script which handles a tool change. We're going to take an M6 command, and we're going to break that M6 command into an actual Visual Basic script to make your program do what you want it to do in a tool change. The reason I picked tool change is that most people want something different to happen on a tool change. There is no one job does all thing which can be done to a tool change. So let's take a look at how we would do that. Here in the screen designer, if we go to page 6, which is our settings tab in the program when you're running it, you can see that we have three DROs called tool change location. In actual fact, these DROs are not used typically in the program unless you determine that you want to use them. If we double click a DRO, let's take a look at what it says. This particular DRO is OEM code 1200. Now, DRO numbers from 1000 to 1255 are user DROs. Those are numbers reserved for you to use whatever you wish, for whatever purpose you wish. Down below here is a format string, which is a way of telling the program how to display data. You can see at the moment it is set to plus 0.4F. This means to display a positive or a negative sign, any numbers in front of the decimal point, and then 4 places after a decimal point as a floating point number. For example, if I was to change this to 0.2F and hit OK, you can see that this number has now changed 2 decimal places. I'm going to take it back up to 0.4F. In CNC, you normally would want 4 places of resolution after your decimal point. I should note that the program really doesn't care how you display it. It will always use up to 12 to 15 decimal points for accuracy. But these are display issues, and most people want that warm and fuzzy feeling they get from seeing the full 4 decimal places after in any number. So, let's say we want to use these tool change locations in our M6 tool change macro. We can see that the X is OEM code 1200, the Y is OEM code 1201, and the Z is OEM code 1202. Let's remember that for the moment. And let's go back to Mach 3. In Mach 3, we have under the Operator menu a Visual Basic script editor. Let's pull it up so we can see what it does. Now this is just a small text editor, and it allows us to open scripts, close them, save them, single step through them. Let's write a very quick program where we say we want a variable called x, and we want that variable to be the value of getUser DRO 1200. Now, as I just showed you on the settings screen, whatever you type into these DROs will become OEM codes 1200, 1201, and 1202. So right at the moment we have a -1 stored in our user DRO 1200. So if we bring up our Visual Basic scripter again, and we tell X to take the value of getUser DRO 1200, and we tell Y to take the value of getUser DRO 1201, and Z to be equal to getUser DRO 1202, at the end of this Visual Basic run, the X, Y, and Z will be equal to the values which are in those DROs, and those DROs are persistent. Whatever you type into them, the program will remember from run to run. Let's check this and see if it works. On the menu here, we have a button that looks like a single step button on a VCR. This allows you to test a program. I usually use two methods to test a program. First, I'll hit run. The entire program just ran. There's only 3 lines in it, but no errors were noted. It didn't tell us anything. If I were to put an error into the program just by typing random garbage and hit run, you can see it tells us we have an error on line 4. A subroutine or a function is not defined, and it even tells us it's KJHLKSHG, which is what I just typed as random nonsense. If I hit OK, the cursor is now blinking on that bad line. If I erase the line and then hit run, the program runs. Now there's another way that you can more tightly test that routine. If we push the single step button, and you can see a tooltip lights up when my mouse is over it saying step into program. If I hit it once, an arrow appears showing that I am on the first line and I'm about to run it. If I hit single step, we go to the next line. So we've just executed the X is equal to getUser DRO 1200 line. If I put my mouse over the X, you can see that it lights up a box saying X is equal to -1. Well, that makes sense, because if we go to our settings screen, we can see -1 is indeed what we have typed into that DRO. If we single step again, we can see X is equal to -1, the Y is equal to 0. One further time, and it's too late for us to check our Z because the program is complete. But Z at that point would have been +3. So let's say that on a tool change, you want your tool to go to a specific coordinate, which will always be remembered in those tool change locations. We can do that by typing code and a quote, and now whatever we put in this statement will be executed as if it's normal G code. Since a tool change location is usually in machine coordinates, you would not want to use a G1 or a G0 to go there. You would want to use a G53, telling the system to go to a particular machine coordinate. So let's use a G53, G0. We're going to do this at rapid speed. And we're going to first move the Z up to its coordinate. So we're going to put a Z and a quote, and this is typical Visual Basic script, an ampersand to join whatever we put there to the Z, and a Z. Now, if we were to test this program, what should we get? Well, the X, Y, and Z that we've just read into the program is equal to -1, 0, and +3. This means when we execute our G53 G0 Z with a Z, it's going to take us to Z3. Well, let's see if we can test that. We'll go to the program run screen so that we can see our DROs, and we'll hit run. And as you can see, the Z-axis just moved to 3.5. But if we take a look at our machine coordinates, it's 3. So it moved to a Z coordinate position of machine code 3. So let's take a look at our scripter again and put in another move. Now, what can be important in some programs is that you delay further statements until a previous statement is done. It's not always necessary, and let's try it without it first. We'll do a code G53. We're already in G0 because G0 is a modal command, and we put a G0 on the previous line. So in this case, we can put X, quote, ampersand X, ampersand, quote, put a Y, ampersand Y, ampersand. Actually, we don't need any more ampersands. That's it. So the line that we're going to execute is G53X and whatever X is, Y and whatever Y is. Now we can test that to see if we're happy with it. And sure enough, you can see the X and Y are moving. And again, don't expect them to go to a relative coordinate equal to what we commanded. It's going to go to a machine coordinate. And as you can see, in machine coordinates, I was way high on my X and Y, so they are obediently going to -1 and 0 in machine coordinates. And there we have -1, 0, and 3 from this simple little script. Now, let's say at that point, we've moved our tool back to a machine coordinate of where we wish to change our tools. We could do other jobs, such as zero those controls. So we can type set DRO 0, 0. This is a Mach 3 command which will set the XDRO to whatever number you put in, and it does that by changing the fixture offset coordinates, or it's the same as pushing a 0 button. We can then say set DRO 1, 0, and test it. We got a syntax error. So, when you test a program like this and you get an error, push the OK, and it will tell you where the error is. And as you can see, it lit up on a semicolon that I put at the end of the line. In Visual C, you use semicolons at the end of all lines, and being a Visual C programmer, I tend to do that just automatically without thinking. In this case, we just delete those semicolons, and we hit test again. As you can see, the axis didn't move, but it did 0. And that makes sense because we were already at machine coordinate 0, -1 and 0 when we did the call. Now let's say that we want to do this whenever we're going to do a tool change. I'm going to hit File, Save As. Now, the macros and the files that are run as macros in Mach 3 are tied into the profile macro directory of your system. If we take a look at the tree here, I am in Mach 3 macros, Mach 3 mil. Now you may or may not be using the Mach 3 mil directory. If your profile is called My Profile, then you would be in Mach 3 macros, My Profile, and in that folder you will find all of your system macros. M6 is a bit of a special one. You'll see that there's two M6 macros. One is M6 start, and the other is M6 end. When you call for an M6, the M6 start macro is executed. The system then waits for you to hit the cycle start button to continue your run. The M6 end macro is called when you hit that cycle start button. Typically, the M6 end macro is empty, but you might have special considerations that you want done after your tool change. We're going to use the M6 start macro, and we're going to save this information into it. You will get a warning saying that it already exists. Do you wish to replace it? And we say yes. So, in essence, this very small macro that we've written only does two jobs. It's going to reach into those tool change location variables, get the data, move to the Z first, then the X and the Y, and then it's going to 0 the X and the Y. We're going to leave the Z alone. Now again, this macro would not be a proper tool change macro for anyone to use. You're going to have your own set of logical rules that you wish to use for a tool change macro. But now we want to test it in the program. So let's exit from the Visual Basic scripter. And let's make sure that in configuration logic, we don't have ignore tool change checked. We're going to have auto tool changer. This basically turns on the M6 start and M6 end macros. So if we now go to machine coordinates and reference our control a bit so that we have strange numbers in our machine coordinates, I'm just going to jog away from these locations so that we can tell that the system is doing something. And let's go to our MDI screen so that we can do a manual tool change. I'm going to leave it on machine coordinates so you can see the end result. And on the settings screen, let's set an X location of 10, a Y location of 10, and a Z machine coordinate of 0, which remember would be at the top of the Z stroke in most instances. Now if we type T01 M6, the M6 part of this command is going to execute the macro we just typed. And as we can see, the Z first goes to 0, the X and Y then go to 10. And we told it to go to 0, 10, 10. But you'll notice they did not 0. It's because we did not put in an additional safety for the zeroing commands. And let's bring up the Visual Basic scripter again and take a look at why this did not work. This button here on the first, a picture of a folder, will bring up our macros. We select M6 Start Open, and there is the macro that we put in. Now the problem here is that we commanded moves, and then we said set the DROs to 0. These DROs were set to 0 during the move. There is a safety command that we need to put between some codes. And whenever you're having strange effects, I recommend you put one. We put the word while, the macro command is moving, and then command wend. This is a while wend loop. A while wend loop based on is moving tells the system to stay here as long as previous commands are executing. When they're finished executing, then execute on into the program. So now this script is going to read the tool change location, execute the commands for movement, wait while it is moving, and then 0 the X and Y. Let's save this by just pressing this Save button, and we can exit the scripter. Let's try this again. T01 M6. Now you see what happened. Now it moved to the correct location. In machine coordinates, we're at 10, 10, 0. And in work coordinates, we zeroed the X and Y axes and left the Z alone. Let's jog away, because we were already at those locations, so that you can see this happen in real time. Now we're going to do a T01 M6. First the Z moves, then the X and Y, and then it zeros. We're at machine coordinate 10, 10, 0. And we have work coordinates zeroed for the X and Y. Now, if we wish to change our machine tool change location, it's very easy. We can put any numbers into this that we wish. A 20, a 5, and a -5, for example. Go to our MDI screen and type M6. And as you can see, it now moved to new locations based on what we typed into the tool change locations. It's a very powerful feature, and it allows you to modify your system to do things that no other system does, because you have needs that those other systems don't have. These macros can exist inside buttons, inside macro files, and indeed you can add the macros to your G-code. Let's say, for example, let's open up the Visual Basic scripter again. Let's say, for example, that you have a special requirement where, for whatever reason, you wish the X to move to a particular location. So we're going to type a code G1 X50, a code G1 Y50, and a code G1 Z0. These are just 3 movement commands. At the end of these commands, you should be at X50, Y50, and Z0 in that order. But we want to do this from within a G-code program. So we're going to save this file, save as. And we're going to call it M666. I realize 666 is the sign of the devil, and I simply use it because macros can be devilishly hard to set up. We have M666. We're going to save it. I'm going to replace the file that was there. Now remember, this file is 50, 50, and 0 in not machine coordinates, but in work coordinates. And we can exit the Visual Basic scripter. From this point forward, M666 becomes a valid G-code command. And when we enter it, we will move at feed rate to 50, 50, and whatever the number was that we put into the Z. And as you can see, the X moves first because that was our first movement line. You can see it's moving very slowly. That's because we told it to move at feed rate. Let's stop the move by pressing the escape key on the keyboard and then raising our feed rate to 500. Now let's type in M666. Now, as you can see, it's moving much quicker. It's moving at 500. And here we are at 50, 50, and 0 in work coordinates. The machine coordinates are whatever they are. And this is because M66 was told to do that. If we tell it to open a file, we open the M666 we changed, and we're at 50, 50, 0, which is exactly where we told the script to go. So that's Visual Basic scripting in a nutshell. You've got the Visual Basic scripter. Remember that you can single step through codes, load and get rid of them. Let's take a look at another code here. Let's go back to our famous M666. You can see if I click on the second line and hit the red button here, which down in the status line will show toggle breakpoint, I can actually run this code and tell it to stop when it hits that line. This means it's only executed one line and will stop and allow me to check variables and do other things, at which point I can continue to single step or continue to run the program to completion. The visual scripting editor can take a bit of getting used to. I suggest that you open other people's macros, play with the macros, and enter in some commands and just experiment to see what you can do. Getting familiar with the scripter increases your power within Mach 3 to an extremely large extent. Let's take a look quickly at the customization document. This is the OEM customization document. In it, you'll find things like the keyboard shortcuts. You don't use these in Visual Basic scripts typically. But you do use button, LED, and DRO codes. For example, to get an XDRO, you say get DRO 0, which is a function code. If it's a function code you're calling, the command is usually get DRO, where if it's an OEM code, it's get OEM DRO. So if we look down the list, for example, we can see that the Z axis reference switch DRO, this is the position that you're going to tell a Z axis to 0 to, the homing, is OEM code 35. So you can find out what value a user has set for this particular variable by saying get user DRO 35. There's a large list of DROs that you can get or set within the program. Most of the time you'll be sticking with the ones that have entries in the user DROs, such as go to SafeZ, which is a button, and you can call that by saying do OEM button 104. Here we have joystick on would be do OEM button 158, for example. There's a lot of commands for the visual scripting engine, and we'll take a look at more of them in the advanced scripting tutorial. This scripting tutorial was really meant to get you used to the Visual Basic Scripter, to allow you to run simple scripts, to learn how to hit the play button, to test a script to see if you have syntax errors or something else going on, and to tell you that you can load scripts from the directory and see what they do. For example, here under spindlespeed.m1s, this is a script which is called whenever you set a spindle speed. So when you type S200 in your MDI line or in a G-code program, we will use the command RPM is equal to get RPM, which puts the value of that S600 command, or the 600 portion of it, into a variable called RPM. We then set the spindle speed to that RPM. Some of you, for example, may want to slow your spindles down by half from the spindle speed which has been entered by a G-code command. You could simply, in between the RPM is equal to get RPM, say RPM is equal to RPM multiplied by 0.5. Again, this is a useless script, but it shows the methodology of doing a script. You can get the RPM value that has been requested, you can multiply it by 0.5, and then set the spindle speed to that RPM. It's a pretty powerful method of modifying the program. In the case of buttons, a lot of the buttons can be modified to do what you want them to do. If we take a look at the screen designer, and we take a look at any of the pages, such as page 1, for example, you can see here that we have an Auto Tool 0 button. By double-clicking it, you can see that it has a simple script in it. You can modify this script to zero your tools to a touch plate or some other such device. And you'll get pretty handy at that if you practice with the Visual Basic Scripter and begin to understand what the commands do. Again, I encourage you to open up the scripter, load a few macros, hit play and see what happens. Make sure that your control is reset and ready to move when you're hitting play on a script if you wish to see the end effect of it. You don't have to save it as a file. You can simply open up the Visual Basic Scripter, type a command like code, quote, G0x10, quote, and by hitting play, your X will move to 10. Play with the commands, play with other people's scripts, get used to the Visual Basic Scripter. If you want to do complex Modbus operations and complex script operations, you'll need to become proficient at it. For those of you who don't intend to do anything other than run G-code, you really didn't need to watch this video, because the video scripts, or the Visual Basic scripts which are added into the program, are sufficient to do most jobs for most users. So that's it for an introduction to Visual Basic scripting.